quick. She is quick.
In your physical packet, we're looking at section 5.5, which might be page 30. Yeah, page 33. If you're at home, Mr. King, let's see, is it page 21? 16, 17, page 17.
17.
So in the physical packet, page 33 is what we're looking at. With the pages 33 and 34 today.
Okay. Anya, what will we do to solve number 1 here?
I can't really remember at the moment.
Okay, what's the opposite of subtracting a 5 over?
Adding 5.
Yeah, so we add 5 first. And we're up to 2x equals 5. And then Anya, what's the last step then? Here, to get rid of that.
Divide by 2 on both sides.
You got that right. And that gives you your answer. X equals 5 over 2 or 2.5. However you like to write it. And then Jason, what's the only difference for number 2? Yeah, you subtract 5 instead of adding 5. So when you subtract 5, what do you get, Jason? Good, and what's the last step? Divide by 2. And you get your answer. X equals negative 5 over 2 or negative 5 or 2.5. Okay, when we're looking down here to factor, we want to first see, is there a GCF? Bill, in x squared plus 2x minus 4a, is there a GCF we could take out? No. Okay, so we want to use our AC method. Remember, AC is going to give us negative 48. Bill, what are the factors of 48? 3 and 16. 4 and good. 5. 6 goes in there how many times? Hey, good. And do any of these have a difference of 2? Yeah, 6 and 8 do. So which one's positive, which one's negative? Good. So we have our factors. We get x minus 6, x plus 8. Now, if we look at 4, TJ, is there a GCF in 2y squared minus 16y plus 32? Huh? 2, yeah, 100%. So we can factor 2 out. When we do so, we get 2 times y squared minus 8y plus 16. From here, we're going to do our AC method. You get the factors of 16. 16, 2 and 8, and then 4 and 4. Funky looking too. Mr. Kimball, what are factors that are going to give us a -8? Good, and they both have to be, yeah. So we got -4, -4. So when we factor this, instead of x, you have a y minus 4 times a y minus 4. And then, don't forget that 2 out in front. And that gives you your final answer. All right, so that is a review. Today, we're going to go into perfect squares, which are easier than what we just did there.
So we're factoring more with a pattern today than we are with a process. So the two examples Mr. King just did with you is more of like a process or a method to use to factor, because you're using two numbers that multiply together to be a top number. The factoring we will work with today are going to deal with special numbers. And if you look at the numbers here, we have 4, 25, and 36. That list could go on, but 4, 25, and 36 are all a special type of number. Does anybody know why they're special? Why is 2, or I'm sorry, 4, or 25, or 36? Why are they special, Michael? Why do you think they're special? What times what makes 4? And what times what makes 25? And how about 36? So Michael just said, oopsies. 2 times 2 makes 4. 5 times 5 makes 25. 6 times 6 makes 36. Or I could say 2 squared, 5 squared, and 6 squared. These numbers are called perfect squares. They are perfect squares because you can take the square root of them and get an exact value. The square root of 36 is 6. The square root of 25 is 5. So that's what a perfect square is. I'd like you to list the first 15 perfect squares. So for a number to be a perfect square, I need to square that number. So if I start with 1, 1 squared is just 1. 1 is the perfect square because 1 squared equals 1. My next perfect square would be 2 squared. And we just said 2 squared equals 4. And then I move to 3 squared. See if you can list the first 15 perfect squares. And then 4 squared, 5 squared, of course, we could go higher than 15. And we might need to go higher than 15, but we'll just list the first perfect 15.
I only know up to 15, so I know.
Not too much. Might go up to 20. I feel like 25 might be more. So again, you might need to use your calculator. Type in 2 squared, 3 squared, 4 squared, 5 squared, and so on. We want the first 15. Michael, what is 3 squared? 9. 4 squared is? 4 times 4. $16. 4 times 4. So that's what 4 squared means. 4 times 4 is 16. So then 5 squared is 5 times 5, which makes 25. 6 squared is 36. 7 squared, 8 squared. Good. 9 squared, 10 squared, 11 squared. Right, 12 squared, 144. Know what's going on with my pen? It made me charged. I did some this morning, but I think it took a break over break. 13 squared. 14 squared. And then 15 squared is 225. So again, to find those numbers in your calculator, you're just doing 14 times 14 or using the squared button if your calculator has a squared button. So you're just taking and squaring those values. If you go the other way, the square root of 225 is 15, and that's what we're going to be looking at today. So we're going to be taking square roots to get the perfect square. So we're going to have the big number, and we're going to go back to the perfect square value. So Mr. King said this is easy, and it truly is because it relies on a pattern. So every problem we do today will look like a squared minus b squared. So maybe x squared minus 9, x squared minus 25, x squared minus 64. But it'll only look like that pattern. So we will not have an ax squared, a bx, and a c. They will just meet this special pattern. And the way we factor with this special pattern is to have 2 parentheses, one always with a plus, the second one always with a minus. Always. So one's always a plus and the other one's always a minus. And inside those parentheses are a plus b and a minus b. To find them, we are going to be taking the square root of each of those values individually. So again, this is not the normal type of factoring. This is called factoring with a pattern because you're given special numbers. So if I take a times a, Bill, what is a times a? Yeah, a to the second, which is how I get that a squared. And Bill, if you take b times b times b is b squared. That's how I get the b squared. Bill, if you multiply a positive and a negative number together, that makes a negative. That's how I get the minus sign. So this is a pattern and gives us a way to factor. Now, there are a couple of things that have to happen. Now, this is my first example here. I made it pretty easy, straightforward. We're going to look at x squared minus 4. So that's what we're working with, x squared minus 4. 3 things, actually 2 things have to happen. First, the 2 numbers must be perfect squares. So pretty much they're going to be in that list. They're going to be perfect squares. The second thing, it must be subtraction. If it's not a difference, it doesn't follow the pattern. And I'm talking about the sign right in the middle. That has to be subtraction. So I have to have 2 numbers that are perfect squares. And it must be subtraction. If it is, we're going to factor it using this pattern. So let's talk about our problem here. X squared, is x squared? Is it a perfect square? Yes. If it's squared, it's a perfect square. Is 4 a perfect square? Yes, because what times what makes 4? 2 times 2. So the way we do this pattern is by taking the square root of each of these. And we're going to just do a little tiny bit of work. There's not much. So the square root of x squared. Jason, what times what makes x squared? x. So the square root of x squared is just x. That's going to be my a value. My b value is going to be the square root of 4, not the negative, just the 4. Jason, what times what makes 4? 2. So again, I'm not multiplying a times c. Instead, total different factoring, we're taking square roots. And now we're going to use the pattern above. So the pattern above has 2 parentheses, one with a plus, the second with a minus. And you're going to fill in those 2 values that Jason just gave me in for A and B. So x plus 2 and x minus 2. And that is it. Notice that they're the same values, both are x and both are 2, but one is a plus and the other is a minus. And that's how you end up getting that pattern, a squared minus b squared. And that's it. So it's always going to be x plus something, x minus something. And the way I get those values is by taking square roots because they're perfect squares. So let's look here at the first problem. Threw in some different variables. We have an m, a q, and a y. Factor using the difference of 2 squares. Again, that's our pattern that we're going to use. So the tiny little bit of work, you're going to say what a and b are. And then we're going to replace those values in our pattern. So Emma, what times what makes m squared? And what times what makes 25? 5. So once you figure out those values, then you're using the pattern. One with a plus, one with a minus. And Emma, what goes in our pattern? So using those 2 numbers. So instead of using a, we're going to replace, so it's supposed to be a plus b and a minus b. So instead of saying a, we're going to replace a with the letter m. And we're going to replace b with the number 5. So m plus 5 and m minus 5. And then that's it. So you're replacing the a and the b with the numbers or the variable from your equation that you're given or your expression. All right, let's look at letter B. This one's a little trickier. We have a Q and 625. Oops. So we need our A and our B. So Michael, what times what makes Q squared? Q. In your calculator, there should be a square root button. If you hit that square root button and plug in 625, it should give you the square root of 625. Michael, do you know what that number is? 25. 25 times 25 makes 625.
Anybody need help finding the square
Yeah.
root button?
So you'll need to use that square root button to find the perfect square or the square root of 625. So 25 times 25.
Later, we'll definitely-
Yeah, and yes. Anybody at home need help finding the square root button? So once you find those perfect squares, then you're replacing them in the pattern. And again, the pattern is A plus B, A minus B. So Michael, what is that going to look like? Yeah, and that's it. So it really is like we're not listing factors, we're finding perfect squares. That's it. You're using those 2 values and placing them in parentheses. Those are the factors. All right, let's look at C. C gets a little different. So again, we're taking the square root of both of them. So Jason, now we have a 9y squared. So let's start with the 9. What times what makes 9? 3. And what times what makes y squared? Yeah, y. And then you gave me 16, which is 4. That first term is both a number and a variable. It's 9y squared. So 3y times 3y makes 9y squared. So make sure you're taking the number and the letter. Both of them go together. And then he gave me the square root of 16, which is 4. So Jason, 1 with a plus, 1 with a minus. What's that going to look like? Nice job. So once you figure out your perfect squares, then you just put them in the pattern. 1 with a plus, 1 with a minus. So if you go to the top of the next page, see if you can do those 3 problems, identical to the 3 we just did. So figure out your A term and your B term. And then factor them using that pattern, A plus B, A minus B. And then Haley, I'm going to come to you for letter A. So Haley, what is the square root of x squared?
X
And the square root of 16 is?
4,
All right, what's that pattern look like, Haley?
X plus 4 and X minus 4.
Nice job. Anya, do you think you could try number or letter B? The square root of p squared. So what times? Yep. And then what times what makes 144?
12.
Good. All right, what does it look like in our pattern? Something plus, something minus. So P plus and P minus. P plus 12, P minus 12. That's a crappy looking 12. All right, the third one. This one's a little trickier. Emma, we have the square root of 4y squared. So what would this square root of 4y squared become? Close. What's the square root of 4? What times what makes 2? There we go. So 2y, and the square root of 81 is 9. So plus and then minus. Excellent. Good. All right, we have 3 problems that we're going to kind of finish with. These problems say, this is your good old factor friend here. Factor the GCF out first. Every single type of factoring we've done has involved the GCF. That's the first type of factoring we started with. And then everything from there, we've always thrown in a GCF. So we have to do that first. Michael, 2r squared minus 18. What would the GCF be there? 2. So you first have to factor out the GCF. We got to take out a 2. You take out that 2, Michael, what do you have left when you take it out? Yeah, minus 9. All right, I'm going to forget this 2 for a minute. You're looking inside. Michael, the square root of r squared is, and the square root of 9 is, all right, 1 with a plus, 1 with a minus. And then what goes in front of those parentheses? Yeah. So we took a GCF out. We forgot it, but not totally. Write it in your answer. So you take the GCF out, you apply the pattern, and then you don't forget about that GCF in the end. Circle it, bring it back in your answer. Let's look at the next one, letter B, 3s squared minus 75. Like, hi, these are both divisible by 3. You know what 75 divided by 3 is? So Nakai, the square root of s squared, what times what makes s squared? Just the s squared. So forget about the 3. We're gonna forget about it. What times what just makes s squared? I'm gonna forget this for now. That's just an s. S times s makes s squared. What times what makes 25? So it's the square root of 25. Not 3 times 3. There you go, 5 times 5, there you go. So 5 times 5 makes 25. So now we use our pattern, 1 with a plus, 1 with a minus. TJ, what's this gonna look like in our pattern? Yeah, and then what goes in the front? The 3, that GCF. All right, final problem. 8x squared minus 98. Jason, did you get a GCF for this one? 2. What happens when you take out a 2? You're so close. How 4x squared minus 49? Yeah. All right, Jason, the square root of 4x squared is? And then the square root of 49 is 7. So square root of 4x squared is 2x. 2x times 2x makes 4x squared. 7 times 7 makes 49. Throw it in your pattern, 1 with a plus, 1 with a minus. So a 2x plus 7 and a 2x minus 7. And then that GCF. Don't forget about the GCF.
Forget that too.
What do you think? Pretty quick. You got to know your perfect squares. Which you have a calculator.
I suggest just making a little list on the right-hand side of your paper on homework.
That might be a great idea.
Every time I do these, I just make a little list, 1 through 15.
Maybe we can,
Do it real quick.
yeah, if this over opens, apparently.
It's on there.
Mr. King said the homework is posted. So if you want to go to Google Classroom, there it is. The homework is posted for you.
Might be able to get it close to done.
Just have to use the one in the pocket.
Got it.
So if you want to open this up, as Mr. King said, it might be helpful just to list the first perfect squares
Yeah.
on the side.
I'll just make a quick list. 1 squared's 1, 2 squared's 4, 3 squared's 9, 4 squared is 16, 5 squared's 25, 6 squared's 36, 7 squared is 49, 8 squared is 64, 9 squared 81, 100, 144, 169, 196, and then lastly 225. And this gets you your squares from 1 to 15. So when you see any of these numbers pop up, like number 1, that's going to really help you out because now you know that your A is just X and your B is 15 because we just did that work on the right-hand side. So Michael, what's my solution going to be then? If my A is X, my B is 15. Yeah. So I think making that list just really makes it a lot easier. Let's jump down to number 6. Nikai, what's my A gonna be and what's my B gonna be for number 6? What number times itself gives you 25? Yeah. And then x squared, you take the square root of that, it's just x. So it's 5x is your A. And what number times itself gives you 100? Or if you take the square root of 100, or you can even go on the right hand side and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You see that your 10th number is 100. So that's going to be 10. We'll use the rule we just found. You get your A plus B is your first part. And your A minus B is your second part. That's all.
That's like number 12.
Yeah, that's what I was looking for. If we look at number 12, TJ, what do we have to do first for number 12? GCF, good. And what is it in this case? 2, good. So if you do that, you're left with x squared minus 81. Michael, what's my A, what's my B in x squared minus 81? Yeah. So when we write the solution, you're going to get x plus 9, x minus 9. Now, Michael, what do we have to put out in front of that? Got it. All right, so we're going to leave you to do these on your own. Other ones that have the GCF, just so you know, are 14 and 15. Let's make a little note by those. Make sure you get your GCF first, okay? If you have any questions, I'll do them with you. If not, rock and roll. We got a couple minutes. One's really small.
We're super zoomed in. When you zoom out, it looks tiny.